I'm Lexi and this is Hannah and we're Wild About Conservation.
This is the podcast where we explore the world of conservation through discussions with our very knowledgeable guests. In this season, our focus is on all things open ocean.
In this episode, we chat with Abby, a turtle biologist who is currently undertaking her PhD in Melbourne, Australia. We chat about turtles, tortoises, and the wonderful experiences she's had throughout her career so far. We loved her perspective on life and the connection she creates to inspire awe and wonder around these beautiful creatures.
It was great chatting with Abby today. We learned so much, just about everything really, what they eat and what they do not, how much data we realistically have on the different sea turtle species, and where her work will specifically be focusing and how her data might inform future conservation measures. We really hope you enjoy listening to this podcast. Please remember to leave us a review, get in touch on Twitter, and if you would like to support us as creators, we do have a Patreon. You can check out all of the links in our show notes and on the website. Enjoy! Hi, thank you for chatting to us today. So can you firstly introduce yourself to our listeners, who you are, what you do, your pronouns, and your key interest in conservation?
Yeah. Hi, I'm Abby. I'm a PhD student and turtle biologist. My pronouns are she and her. So I'm from England originally, but I moved to Melbourne, Australia to undertake my PhD at Monash University. So I'm based in the Ecophysiology and Conservation Lab, and my project is on turtle conservation. So as you probably guessed, my specific conservation interest is to do with sea turtles and freshwater turtles.
Just the title turtle biologist is so cool. But before we do get into all things turtle, we do have a short game that we like to play with our guests. It's a really fun quickfire round of a couple of questions to keep you on your toes so that we can get to know you a little bit more and our listeners get to also. So,
Sure.
If you could fly, breathe underwater or hibernate, which would it be?
Oh, breathe underwater.
I thought so. Most people have answered that, which I absolutely respect. If you could be any animal, what would it be?
That's a tough one. I love them all. Actually, probably a bird. Something that can fly, travel the world.
Like an albatross. Okay, sorry, I'm just getting distracted. Thinking about animals. What is something that you're grateful for today?
I'm definitely grateful for my family. Yeah, they've always been there through my sort of conservation journey and my academic journey. So yeah, very grateful to have them.
I feel this is going to be a very wholesome podcast and I'm already enjoying it.
Yeah, I've got all the love for the wholesomeness. And also, Abby, I feel like you cheated there because we gave you the choice of fly, breathe underwater or hibernate. And then you picked bird.
I know.
So you got the best of both worlds, which was sneaky. But I would do the same. So I respect that. Finally, every episode, we also ask our guests another question. And, well, among many. But specifically, how you get wild about conservation. So it could be anything. What you do, what you like doing, or what you read or anything like that. So, Abby, how do you get wild about conservation?
Oh, that's a good question. So, I mean, for me, it's always been a natural interest. Like, I love wildlife, I love conservation. Something that really, really gets me excited is when I get to share that passion with other people, so especially other people that aren't necessarily in the field of conservation or biology. So, for example, if we have volunteers with us on a project and they're seeing sea turtle hatchlings for the first time and they're, beyond excited, they think it's the most amazing thing in the world, I absolutely love that.
Oh, I love that. I think there is something that is experiencing life, even if that is your job or your local park or like your pets, through somebody else's eyes can really reignite that excitement. And I adore the fact that you mentioned that. So another hard question, I think, that we ask all of our guests is, what got you into conservation in the first place?
So, like I said, I can't really pinpoint a particular moment where I was like, oh my gosh, conservation. I've always been into animals and wildlife. I remember when I was younger, I think I went down the dolphin trainer route. I watched a lot of documentaries on TV, like Free Willy and all the sort of charismatic animal movies. And then I went into big cats for a long time. I was really interested in big cat conservation. I always wanted to do the sort of cliche safari in Africa. And then I went into marine biology. So yeah, I've just always loved surrounding myself with wildlife and with animals. It really makes me happy and I love what I do. So yeah, hopefully I can share that passion with other people as well.
I love that because I feel like I know a few kind of marine scientists that for some reason big cats is the other one they gravitate towards.
Yeah.
So that's real interesting that you also had that gravitational moment to big cats and then kind of started towards the marine environment. And that leads me nicely to my next question, which is what actually made you fall in love with the ocean? Can you pinpoint that moment?
I actually can. Yeah. So before I started my undergraduate degree, that was when I was all about big cats. So I did zoology for my undergraduate degree. And for that, I moved from Yorkshire, not surrounded by coastline at all, to Cornwall. So the university was right on the coast. You could see the ocean from the labs, from the lecture theatres. It was beautiful. So there I took up snorkeling. I got my scuba diving qualification. I worked on a wildlife watching boat. So I was just completely surrounded by the ocean. And I just fell in love with it. Yeah, it was beautiful there.
Oh, that sounds lovely. I've only visited Cornwall a couple of times, but it is just, it feels like another world. It doesn't necessarily feel like the United Kingdom, but I feel you can also find places like that in a lot of our coastline, especially Scotland. So yeah, you've mentioned that you've kind of bounced around from dolphins to big cats, and I think we've all been on those journeys. What made you finally land with turtles?
So at the end of my first year of my undergraduate degree, I really didn't have much conservation experience at that point. So I was looking for something to do in the summer just to get some more hands-on experience. And a friend recommended a sea turtle conservation project in Greece. So that was with loggerhead sea turtles. So I gave it a go, and it was my first time going abroad by myself. So I was really nervous. I think I was 19 at the time. And yeah, I saw the nesting female sea turtles and I saw the hatchlings coming out of the nests and going to the water. And it sounds so cliche, but I literally just fell in love with them on the spot. And I was like, this is what I want to do. This is my species. This is my thing. And yeah, I've been obsessed with turtles ever since.
I feel like those moments are moments that you will never, ever forget.
Absolutely. Yeah.
And just because you've touched on it as well a few times, kind of the university, but also this kind of, I guess, volunteer abroad program. Can you give us a quick overview of your university career so far and kind of what got you to this point academically, and maybe also like the different internships? Because knowing you, I know that you've done quite a few different things over the years.
Yeah, I've bounced around quite a bit. So like I said, I started off with my degree in zoology. So that's where I switched from big cats to having an interest in the marine environment. And then when I finished that degree, I went on to do my master's in marine biology because I decided I really wanted to specialize in the marine field, but I didn't want to go straight into pure research just yet. I wanted still some taught modules just to get more of a background on marine biology that I didn't necessarily get during my undergraduate degree. And then now I've moved on to do my PhD, which is specifically in turtle reproductive biology. And then just an overview of my internships. Like I've said, I've bounced around. I love everything. I love everything marine. I would happily work with any marine animal thrown at me. So I started off with some dolphins and seals, seabirds in the UK because I worked on a wildlife watching boat. So I got to see all kinds of native marine wildlife, which was amazing. And then I've worked on a couple of conservation projects with sea turtles. So the project in Greece, which was with loggerhead sea turtles, and then in Costa Rica, which was with leatherbacks, green turtles, and olive ridley sea turtles. And then right before I started my PhD, I was working in Scotland as a photo ID research assistant. So that was taking photographs of harbour seals. So yeah, quite a few different animals there.
Quite a world trip as well, you'd say, from Greece, Costa Rica, Scotland, which we all love, and now Australia. So how far through your PhD are you, and how is life in Australia?
So I started my PhD in February last year, so I've been here just over a year. So I'll be coming up to my confirmation soon, which is at the end of my first year. Unfortunately, it coincided with the time when the whole COVID thing kicked off. Well, I say unfortunately, but for me, I say that's fortunately because I feel like I've been in a much better position here than I would have been in the UK. But of course, that hampered my ability to do field work. So I haven't actually been able to go very far. But what I've seen of Australia so far, I absolutely love. There's so many opportunities here for me, especially with marine biology. You know, we're right on the coast in Melbourne. I've seen dolphins, seals. I've gone snorkeling. It's beautiful. So I do really love Australia, and I'm definitely looking forward to exploring more.
Yeah, I'm certainly looking forward to eventually coming to visit you, Abby.
Yes, please.
And also, yeah, right before we actually started recording, we were chatting about the temperature difference. And even though it's very sunny in Scotland right now, we are recording in April for this episode. It is considerably colder here than it is in Australia, as you can imagine. So, obviously, your love is turtles. And we're going to get into the nitty gritty now. So, can you tell us, what is a turtle?
Sure. So turtles are reptiles. So that means they're ectothermic, which means that their temperature fluctuates with the external environmental temperature. And I'll quickly say there is one exception to that, which is the leatherback sea turtle. So just because they're so big, they're able to essentially maintain part of their body temperature. So for example, when they're swimming in the ocean, they can shunt blood towards their core, so it keeps their core warm. But then when they're nesting, they can shunt the blood towards their flippers so they don't overheat. And then obviously they use the flippers for digging a nest. And then in addition to that, turtles lay eggs, and then the eggs hatch into live young. And there's no parental care at all with turtles. So the females will come and lay their eggs, they'll cover the nest, and then they disappear and they never see the hatchlings again, which is a little sad, quite different to humans.
A little sad, but then again, how many sea turtle eggs could be in a nest or a clutch?
Yeah, that is true. So they do compensate for the lack of parental care by laying big clutches. So, for example, the biggest olive ridley nest I've seen had 133 eggs inside it. So they're one of the smaller species, so they lay smaller eggs and more of them. And then the opposite end with the leatherbacks, they lay bigger eggs and slightly fewer, but they're still a good size. There's normally about 60, 70 eggs in a clutch. So they do lay quite a few eggs to sort of compensate for the fact that they don't give any care to the eggs after they've been laid.
And I think it's just the way most reptiles work. But can I ask you probably one of the biggest questions for anybody that's starting out and learning all about turtles? What is a turtle versus a tortoise?
It's a good question. So the main difference is that turtles are adapted for life in the water. So this is sea turtles and freshwater turtles. So their shells and their limbs will look slightly different to a tortoise, and a tortoise is adapted for life on land. So you'll notice with sea turtles and freshwater turtles, they have more specialized flippers. So in the freshwater turtles, it's kind of like webbing, a little bit like duck's feet. And then, of course, sea turtles have the big flippers that are adapted for swimming. And they're both a little bit more streamlined as well. And then tortoises have the sort of stubbier kind of legs for walking. And then in addition, sea turtles and freshwater turtles eat a variety of different foods, so they're omnivorous, whereas tortoises are predominantly vegetarian.
I'm just having these images that if you'd never seen a freshwater turtle, of a freshwater turtle with duck legs.
Yeah, it's the little like webbing like duck's feet. That's the only way I can describe it.
I love it though. It's like a shell duck for Avatar.
Yeah.
It's probably where the idea came from, actually. So most tortoise, they can retract into their shells, but I don't think that turtles can.
Yeah, so sea turtles and freshwater turtles can't leave their shells, but freshwater turtles can actually retract their heads and their limbs into their shells, like tuck them away, but sea turtles can't. They're fixed.
Thank you so much for that explanation, because I remember when I very first started out and I did something similar to you and go on an volunteerism holiday with a friend to a Greek island and started learning about sea turtles. And yeah, it was one of those things where you're like, right, some places call them turtles, some places call them tortoises. They're totally different animals. And it is a lot, I think, when you're getting started to get your head around. So yeah, how many species of turtle are there? That's sea and freshwater.
So altogether, there's 356 species. That includes freshwater and sea turtles. But of that, just 7 of those are sea turtles. yeah, not very many sea turtles.
And how big actually are they? Because there's obviously the ones we've got today, and you've already mentioned leatherbacks, but I'll let you go into how huge those things are. But there's also the turtles of the past, which I think like most animals were pretty big, right?
Yeah, so the biggest ever species of turtle was Archelon. So that's of course extinct now, but that one could grow to over 4 meters, which is pretty amazing. And then if you follow that on today, the largest species of turtle that's currently alive is the leatherback sea turtle. So they can be, the ones I've seen have been in the region of maybe 1.5 meters in length, but the largest one that's ever been discovered was unfortunately caught in a fishing line. That one was 3 meters in length and it weighed 914 kilograms, which is amazing.
That is an intense weight. I couldn't even imagine a sea turtle that large.
It's literally my car.
A small car.
So yeah, for this podcast we are obviously focusing on sea turtles, but it's really good, I think, to have this kind of like overview and background knowledge of the freshwater turtles and turtles versus tortoises. So just on sea turtles now, where can we find them globally?
So, like I said before, turtles are ectothermic, so it means that the temperature fluctuates with the external temperature. So generally, sea turtles will be found around the tropics, so just sort of either side of the equator where it's the warmest. Unfortunately, if they go into waters that are too cold, they end up being cold stunned, which means essentially it just stops their muscles from working, so they can't swim, and they'll drown, unfortunately. The only exception again to that is the leatherback. Like I said, because they're so big and because they have these countercurrent heat exchangers, so the ability to sort of shunt the blood to maintain their temperature, they can occupy slightly colder waters. So it's completely normal to be able to see leatherbacks off the coast of the UK, for example, and all the way up off the coast of Canada. Even though they don't nest there, they're able to swim up to much colder waters than the other sea turtle species, which is really impressive. I had no idea they could occupy areas that were that cold.
Yeah, I think in the past I've seen articles of leatherbacks on UK coasts, and I'm like, this makes no sense to me. But I didn't know that about their heat regulation. That's really cool.
Yeah, I know a few people that have been out on boats and they're like, oh, what's that oh my gosh, it's a sea turtle. And I'm like, oh, just that day, imagine being on a dive and just a leatherback swimming past, which is probably never going to happen, but it would be pretty insane. And Abby, you mentioned that obviously the tortoise is vegetarian, but sea turtles specifically are omnivores. So what do they actually eat then? Is it just anything and everything that's going, or do different turtles have kind of specific diets?
So it really depends on the species. Each species is adapted for a slightly different diet. So starting off with the leatherbacks, their primary diet is actually jellyfish. So they have to consume an enormous quantity of jellyfish for their size. And they have these little hooks in their throat. If you Google like a picture of a leatherback, it looks really cool, a leatherback throat. And they have all these little sort of soft hooks which stop the jellyfish from coming back up to keep it going down the throat to the stomach. And then hawksbill sea turtles, they have a sort of hooked beak at the front, so they feed primarily on sponges. So they're found around rocky reefs, and they'll sort of burrow into the reefs and eat the sponges. Loggerheads have really big heads and really big beaks, so they're primarily adapted for being able to crush their prey items, so that can be like crustaceans and mollusks. The Ridleys are pretty generalist, fish, crustaceans, a pretty good mix of things. The green sea turtles are also primarily vegetarian, so as adults they'll feed mostly on seagrass, but as juveniles they'll eat some microorganisms as well. What's the other species? We got one more. I think I covered them all. Yes.
I was trying to count through them in my head.
I know, I was like, have I got to 7? Oh, the flatback. I forgot the flatback. We actually don't know too much about the flatback. That's the one that's endemic to Australia, but I would assume that they have a pretty generalist diet as well.
Thank you for talking us through all those. It's quite nice to hear that different species do have different adaptations depending on where they live and stuff, so it kind of makes sense. So with sea turtles being reptiles, and I know they don't have gills, how do they breathe?
So turtles are air breathing, so they do need to come up to the surface to breathe oxygen. So they can hold their breath for a really long time, but yeah, they have to come up regularly to breathe oxygen. So they have lungs just like mammals do.
So that's how we can see them poking their heads up and maybe spot them in the UK. That's cool. And where do they sleep? Do they, because that's a whole thing of like ocean things. Because actually, yeah, if they have to come to the surface to breathe, how long do they sleep as well?
Yeah, this is quite interesting. I don't know if anyone's actually sort of recorded the sort of maximum time frame that a turtle has been seen sleeping for. But they'll generally sleep on the go. So of course they still have to come up to breathe oxygen, but when they actually go back underwater, they can slow their metabolic rate down so they don't consume as much oxygen. So their oxygen consumption is a little bit more efficient, and then they can stay longer underwater. So they'll generally just sleep. I've seen videos of them, sleeping up against rocks and things like that. Yeah, it's pretty interesting.
Take a turtle nap.
Yeah.
I couldn't imagine having to hold my breath or reduce my breathing to sleep because I don't even think about it. But then again, I don't live underwater, so it's not for me. Right, back on track. What is the average lifespan of a sea turtle? I imagine this once again differs by species.
Yeah, it would differ slightly by species, and again, I'm not too sure if anyone actually has because you can track turtles by their tags. So I don't know if anyone's actually monitored a turtle from hatching to sort of old age, because it's very difficult to track the hatchlings. But we say roughly the average age is maybe 70 years. So similar to humans. So they'll start to become sexually mature. In leatherbacks, it's 15 years of age. And then in the other species, it can be anywhere up to 25 years. So that's when they'll lay eggs. And then, yeah, they can live up to 70, 80 years. But yeah, I'm not too sure what the world record is. They're pretty long-lived species.
I had no idea that leatherbacks sexually matured so late, which is one of the things with these big animals that is kind of the risk to them, is that when they are so slow growing and get so huge and then have babies real late, if something happens early on in life, which we're going to get into a little bit later, it can be pretty bad for populations. So you touched on it very quickly earlier about turtles coming to shore, but how do they actually reproduce? How do turtle babies get made? And males and female turtles, are they easy to tell apart, or is it that you have to get real close and personal?
So just to start off with, it can be quite difficult to tell males and females apart. So one way is to look at their tails. So males will normally have really long tails and the females don't. But of course there's exceptions to that, so it can be quite difficult to do without using like an invasive procedure to sex them. And then just on the reproduction, again, it's one of those elements, because it's all done in the water. It can be very hard to sort of study and figure out. But generally, for all the species, males and females will travel to specific breeding sites, and then females will actually mate with more than one male, and they can store sperm from different males and then use that sperm to fertilize successive clutches of eggs. So that'll increase the genetic diversity of their offspring, which is really, really cool.
I didn't know they did that. That is awesome. I mean, the amount of animal adaptations out there, I'm not going to ever know them all. But this is a very good way to start finding them out. Abby, can you, since we've kind of touched upon this a little bit, can you explain what we know of the general life cycle of a turtle?
Sure. So I'll talk through, say, the green turtle as an example. So, of course, you have the females coming onto the shore to lay the clutches of eggs, and then those eggs will incubate, and then eventually, for green sea turtles, after about 60 days, those eggs will hatch. So the hatchlings will make their way to the ocean. And this first part of the sea turtle lifespan is really interesting, and we actually don't know very much about it. So the time frame from when hatchlings enter the ocean, so after they've crawled down the beach and gone into the ocean, to when we see them again as juveniles, is called the lost years. It's very difficult to track sea turtle hatchlings because they're so small, and the rate of predation on them is very high. It can be really difficult to actually know where the hatchlings go. So we do know that they will actively swim, and they'll also use passive currents. So somehow or another, they do actually end up out in the open ocean. So, for example, green sea turtles from Florida, say, will swim out into the open ocean, and they'll get carried by currents. And then eventually they'll end up in the North Atlantic Gaia. So that's a massive current which has got a really high area of productivity. And the hatchlings will stay there for several years feeding until they become sort of juvenile age. And then those juveniles will come back in to inshore foraging areas where there's a lot of seagrass. And that's where they'll feed on the seagrass, which is what the adults primarily feed on. And then they'll move to breeding areas as adults breed, and then the males will just disappear offshore, and then the females will stay relatively close to the shore and then come up to nest, and it starts again. So yeah, it's quite interesting. It's very difficult to monitor because the lifespan of turtles is so long, and also the duration to get up to sexual maturity is also so long. It's very difficult to track an individual hatchling all the way up to adulthood. But it would be really cool if one day we had the technology to put a tag on a hatchling and follow it all the way through.
Yeah, that would be awesome. So is it true then, and do we know this, that if a sea turtle was born on a particular beach, that it will return to that beach to nest?
Yeah, so that's the generally accepted idea that hatchlings that emerge from a nest on a beach will return to that beach as adults to nest. Of course, not in the same spot, but they would return to the same beach. How they do that is, oh gosh, it's amazing. My favorite theory is that they use the electromagnetic fields of the Earth to navigate, kind of like a compass. And from that, they're able to navigate their way back to the nesting beach, which they hatched on. Really amazing. Again, it's very difficult to study, but I think that's really, really amazing how to do that.
I think that is so amazing, though, is because they go back multiple times in a season as well? So it's that kind of navigation of being able to navigate whatever area it is that they're in. You just mentioned, because I remember how years ago when I first came across sea turtles and was lucky enough to meet a sea turtle and do lots of different sea turtle work, that we also had the conversation about the lost years and the size of tag that you'd need, and that predation rate was so high. So convincing someone to pay for those tags would be pretty difficult when you're going to lose loads of them in the first 24 hours. But what actually is kind of the rough accepted predation rate, what people tend to think of, either within the first 24 hours or how many actually make it to being adults that have the potential to come back and lay an egg?
So yeah, unfortunately, the predation rate on hatchlings is extremely high, and that's both on the land, like on the way to the ocean, and then during the first few weeks when they're in shallow water. So pretty much, essentially everything and anything will eat a hatchling, you name it. Birds, crabs will take hatchlings. I'm sure a crocodile would take hatchlings if they wanted to. They've been found inside big fish as well. So yeah, unfortunately for the little hatchlings, the predation rate is really high. And as a result of that, only 1 in 1,000 sea turtle hatchlings will actually survive to adulthood. But like I said earlier, females lay several clutches of eggs within one nesting season, and there's also quite a few eggs within each individual clutch. So they do produce a lot of hatchlings.
And just while we're on the topic of hatchlings and babies and eggs and the cute versions of birds, I've heard, is it Cool Dudes Hot Chicks?
Yeah.
Can you just talk? I'm just going to leave it there. You go at it.
Yeah. This is really another thing that I find absolutely amazing. One of 1,000 things I found amazing about sea turtles. So the temperature during incubation determines whether the hatchlings are predominantly male or female. So the accepted sort of pivotal temperature for a 50-50 sex ratio is 29.4 degrees Celsius. And anything above that, and you'll have a shift towards more female hatchlings. and anything cooler than that, and you'll have a shift towards more male hatchlings, which is where you have the cool dudes, hot chicks. But generally a good ratio to have is 60-40, so 60% female, 40% male. But of course, with the current rate of climate change, nesting beaches are getting warmer, so we're actually starting to see nests that are producing close to 100% female hatchlings, which of course in the long run is not good for genetic diversity.
And why is it that there's the kind of optimal sex ratio is 40-60?
I think because females will mate with several different males. So one male can essentially mate with many different females.
Okay,
so
cool.
I think just to maintain the ratio, it's having more females to males, just so there's a greater genetic diversity.
Yeah, because both of them are mixing all over the place. You mentioned obviously tagging and a little bit about kind of where the turtles go during their lifespan. For the turtles that we can potentially track a little bit more, how do we actually know where they go? What methods do we use to get that kind of data?
So there's many different ways of tagging. So the ones that will actively monitor where turtles go is satellite tagging. So I've done a little bit of this myself with hawksbill sea turtles. So essentially it's a transmitter, and luckily nowadays they're a lot smaller than what they used to be. They used to use big harnesses, but now with technology improving, we can use much smaller devices, and those are attached to the carapace just with epoxy. So use a couple of layers of epoxy and let it dry to make sure it stays securely on the shell. And then every time the turtle comes up to the surface, that'll ping back a location, and then in the end you'll end up with all these different coordinates of different locations where the turtle has broken the surface. And then you can essentially draw a little, or at least the software will draw a map for you showing the route that the turtle has taken. But of course, satellite transmitters are, as you would expect, very expensive. I think the ones we were using were about $1,500 each, and they will just fall off the turtle eventually, so you don't get those back. It would be nice to do more with those, but yeah, of course, it depends on funding. So the other techniques that a lot of projects use, so these won't actively tell you where a turtle is at sort of any given moment or give you sort of like a sort of route that the turtle has taken. It lets you know where a turtle is nested or where a turtle has been sighted. So these are PIT tags, which stands for Passive Integrated Transponder tags. So they're essentially like the little microchips that you'd have in your pet cat or dog. And when you see a turtle nesting on the beach, you can scan the turtle and it'll give you a number. So then you can look and see where that turtle is nested, how many times she's nested, how many seasons of nesting she's done, whether she's skipped a season. So it can give you some indication of if the turtle is moving around, if she's been spotted at several different nesting sites. And then the other tagging method that's also passive is using little metal or plastic flipper tags, and they're the same thing where they have an individual number that's engraved on the tag, and they're just pushed through the flippers, and then a researcher can manually read those if they encounter the turtle.
Thank you for talking through all those different tag methods, because the last one that you mentioned is very much the same that we use on cattle that you may have seen on sheep as you pass the field, just like more or less an earring at this point. So we've got that method of like identifying turtles, which makes sense, and the use of technology I think is really good because it really helps that kind of like error. But how, if we've got pictures of two turtles and they don't have an ID tag, how can we tell one turtle from another?
So that can actually be very difficult, especially if you're just looking at the carapace, so the shell alone, because they can be covered in barnacles and algae, so it can be quite difficult to notice differences in the scute patterns. But one method that I know has been trialed before is using photo ID software. So similar to what I've used before with seals, where you can look at the pattern of the spots to tell individual seals apart. Researchers have tried to look at the facial scutes, so the little scales on the face of hawksbill sea turtles, to tell two individual turtles apart and run it through the software. I think we've had some success with that, but of course you need to have really good pictures to do that. But I think they're trying to encourage divers to take photos and then send those photos to the researchers so they can try and build a catalogue of different sea turtles in the area. So I think that's a cool alternative.
Yeah, it's a really interesting way of doing it because it was the way I managed to get my deepest and longest free dive was trying to get a sea turtle face profile photo, and I got it, but then I did spend a lot of time going through and using one of these softwares to try and build up a database, and I think that's the thing. There is no way that you can look at two turtles and say, oh, that's this one and that's this one, without having that backup in a database. But it is really interesting that there are many marine species that we can tell from their different patterns and scoots and different things. So I think it's really cool, and it was a really interesting project to be involved with for a little bit. So yeah, we've mentioned about their life cycle and how like they produce tons of babies, but not many of those tend to survive from what we're aware of. Does that mean all sea turtles are endangered?
Officially under the IUCN Red List, all the sea turtles are listed as either vulnerable, endangered, or critically endangered. And there's one exception, which is the flatback, which is data deficient. So it means we don't have enough information on the population to give an idea as to whether the population is increasing or decreasing. But all of the species of sea turtles are threatened. So I always like to take those listings with a pinch of salt. So I think regardless of whether they're listed as vulnerable or critically endangered, all sea turtles are unfortunately exposed to the same threats in the environment. So it's really important that we focus on conserving them as best as possible.
And that's real interesting as well, with such a charismatic species, that there is still that one that there's not that much known about. So anyone listening, there's always more work to do, as I think we say in every episode, that it isn't just pure hard fast one thing when it comes to conserving these kind of species. There's always more stuff to be thinking about and doing. Just thinking about what you said, Abby, about the interactions obviously with their prey, who or what else should I say do turtles share their habitats with? Are there any symbiotic relationships that you know of? Are there any big predators of sea turtles that are kind of, we could be picturing or thinking about?
Unfortunately, the main threat to turtles is humans. But then in terms of marine predators, the biggest predator of sea turtles is sharks. So of course, with the bigger species like leatherbacks, I imagine it would be difficult for a shark to take down a leatherback. But definitely some of the smaller hard-shelled species, like the Ridley turtles, sort of juvenile green turtles, a shark would definitely try and take one of those. But turtles have this really cool defense mechanism where they'll actually spin their carapace. So their shell, they'll sort of tilt on the side and almost deflect the shark, which I think is really cool. And just on a side note, I saw a really cool paper where they were actually trying to put models of sharks, like a literal huge plastic model, and hang that on the outside of a fishing net to try and deter turtles from coming too close and getting caught in the fishing nets, which I think is really cool.
Oh, wow.
And then just on the symbiotic relationships, the only one that I'm aware of, there might be more, is the cleaner fish. So there'll be these little cleaning stations on reefs where there's these cleaner fish which will come and essentially eat all of the gunk off the turtle carapace. So yeah, the cleaner fish will get a free food source there, and then the turtles get their carapaces cleaned, which is really beneficial because it'll definitely help the streamlinedness. That's not the right word.
Reduce drag.
Yes. Reducing drag of the carapace by removing all of the dead stuff on there, or living stuff, like algae and little barnacles and dead skin and all that lovely stuff turtles pick up while they're moving around.
And I think that's really cool. Like some of these symbiotic relationships we don't tend to think about, especially when, Hannah and I are creating this podcast and we very much focus on somebody's work. And it may not encompass some of these holistic views of what happens on a reef or in the ocean or whatever. So it's really nice that you're able to talk to us about some of those. But now a little bit more into you, Abby, and what you do in your current PhD life. How do you study turtles? What data do you collect? What does a day in the life of a sea turtle researcher, or a turtle researcher, look like?
So at the moment, my project, the broad theme, a rough title that I have, is factors that influence reproductive success of turtles. So originally I was just going to do sea turtles as my focus, but because of COVID, I've brought in the element on freshwater turtles because that's something I can do quite locally, and I actually now think they're really, really cool. So that's a bonus. So typically, I know people would expect a turtle researcher to be out sort of in the water every day, on some tropical beach, but I actually do spend a lot of time on the computer at the moment. There's a lot of paperwork that has to be done, a lot of research before you can go out and do that field work. And then, of course, when you come back, there's all of the data entry. But when I actually go into the field, I'll be doing surveys of nesting females for the sea turtles. So I'll be walking up and down the beach to look for the females as they come ashore to nest. And then for freshwater turtles, I'll actually be actively trapping the turtles. So I'll be setting nets to catch freshwater turtles. And then later in the season, I'll come back and try and find the nesting females. So for both sea turtles and freshwater turtles, what I'm wanting to do is take blood samples to analyze for the presence of environmental contaminants, and then see if those contaminants are transferred to hatchlings, and if so, do they have any impact on hatchling fitness? So, for example, hatchling size, their crawl speed, their ability to self-right, so that means flip back over if they're turned onto their carapace, and then also if that impacts the hatching success of the nests as well.
That's really interesting, all those different sides of things and how, like, what you're looking at and how that then has these different effects. And also noting that, much of a life of many researchers is at a desk. As much as we want to be outside all of the time, there is still that kind of, your stats and all those little bits of things as well. So you touched on it a little bit earlier and kind of there as well. But what are actually some of the pressures that we're seeing on sea turtles, either anthropogenic or environmental? I know your work focuses on kind of the ecotox, but you already touched sort of on temperatures and maybe some of the other things that might be going on that's affecting the success of the species.
So yeah, as I said, at the moment, the first component of my PhD research is looking at chemical pollutants, which can impact reproductive success. And then in addition to chemical pollutants, there's also physical pollutants, so like plastic pollution, which is unfortunately quite problematic for turtles because they'll mistake plastic for prey, especially the leatherbacks, which feed on jellyfish, because jellyfish unfortunately look very much like plastic bags. And then, like you mentioned, there's temperature. So with rising global temperatures, that comes with it the increase in temperatures on the nesting beach, which can affect the sex ratios of nests. Also, there's sea level rise as part of climate change, which is essentially limiting the amount of nesting area the females have. There's also coastal squeeze, so that's partially caused by sea level rise, but then also development along the back of the beach. So it's greatly reducing the area available for nesting females. And then also with development comes light pollution. So at the back of the beach, if you've got hotels or houses, things like that have bright lights, they can actually disorient the hatchlings when they come out of the nests. So again, there's many different theories as to how hatchlings find their way to the ocean. But one is that they use a light source, so the light from the moon, typically, at least reflected off the ocean. So if you have a brighter light source at the back of the beach, like from a hotel or a restaurant or a street light, the hatchlings will go towards that light source at the back of the beach, and then unfortunately they will never make it to the ocean. So yeah, there's unfortunately many different things impacting sea turtles at the moment.
Yeah, I think it's a pretty long and upsetting list. Your focus is on the ecotox work, and I know obviously with the last year and COVID having a little bit of a impact on the entire world, it's not been the kickstart to the PhD that you necessarily wanted. But what are some of the applications of your PhD going to be? I know this is a very left field question. So.
No, so I've thought about that quite a lot. So especially with the ecotoxicology work, I think that's got a really good conservation outcome where you could say, okay, turtles in this area are being affected by this pollutant and it's actually impacting their reproductive success. So maybe we can go away and look at the way in which we treat wastewater or how we can manage runoff of chemical pollutants from the land. Maybe we need to incorporate greater water monitoring to sort of monitor these pollutants because it can be very difficult to measure. You don't think about all the pollutants that are in the ocean. So hopefully that has a direct conservation impact. But also on the other hand, we might find that, turtles are doing completely fine in an area and, they're not impacted by contaminants at all, which is really, really great. So yeah, for the first part of my PhD, that would be a good conservation outcome. But as a whole, I'm hoping to have a conclusion as to what's affecting turtle reproductive success and then possible interventions that could come from that data. So how can we improve reproductive success?
I think that's so great, kind of summing up that real world view of where this data goes and how it could be applied, and kind of it links back to everything you just mentioned in some way or another, a little bit by little. Kind of researchers around the world are building these building blocks to make these changes and hopefully help to conserve different species. We've already heard a little bit, Abby, about the different projects that you actually worked on. And obviously you've mentioned some of these pressures. So how did these kind of projects that tend to be on, say, a nesting beach, and like you said, that you might be looking at the actual nests themselves or even just attaching satellite tags, how do these projects actually help to conserve turtles? What do they actively do out on those beaches or in the water?
So, yeah, just before I go into the actual physical sort of nest protection and things like that these projects will use, I'll say that, in my opinion, the most important component is definitely education and community outreach. I feel like without that, you can do physical interventions on the beach, but unless you have the involvement and the support from the local community, I feel like the impact of that is fairly limited. So definitely having schools involved, the local community involved is really, really, really important for getting the message out there as to, sea turtles nest here, here's why they're important, here's what you can do to help, and spreading that word as well. And then the actual physical sort of conservation interventions that are used, it really varies by project depending on what the threats are. So, for example, in Greece, they have a really high rate of predation of the nests by stray dogs. So they would use physical nest protection, so like a piece of wire mesh that you put on top of a nest after it's been laid, and you secure it in the ground with, we just used bamboo from the beach. So that prevents dogs and foxes from digging up the eggs and eating them. And then other projects focus more on increasing the hatchling output, but not from nest protection, but by using a hatchery. So the project I worked at in Costa Rica would move nests into a hatchery and protect them off the beach in there, because it was a public beach, so they weren't able to put the nest protections actually on the beach. So by moving them off the beach and protecting them in a hatchery, it stopped the raccoons from digging up the nests. And then also there's projects that work primarily sort of offshore, which I haven't got much experience with, but that can be developing bycatch mitigation strategies. So bycatch is in accidentally catching turtles in fishing gear, because that's obviously not intended. So there's all kinds of things like turtle excluder devices, which were developed, like little trap doors in fishing nets to allow turtles to escape. I know there's been a lot of research on trying to develop, different colored floats for the nets, using like that shark model I described earlier to deter turtles. So some projects are very heavily focused on that, but I certainly think you need to have a mixture of both. So conserving nests on the beach, but also trying to protect the turtles offshore, because like you said before, if turtles take so long to reach sexual maturity, so you can protect the nests on the beach, but if you're losing juvenile turtles in fishing nets before they've had a chance to reproduce, that really impacts the population.
Yeah, I think what you've mentioned there is it can be a little bit overwhelming that there are so many points of this stages of a sea turtle's life where things can go wrong, from initial hatching to those lost years that we don't really know, and then as adults. It's quite worrying, and like you say, a lot of the research that's done is in the marine environment, which is difficult enough, and then you try and add conservation to that. We are doing things, but I think it's just a nice highlight that there's always more that we could be doing, as a scientific community and as a conservation community. So that kind of segues quite nicely into my next question. Is there any way that people can help if we're at home? So I know, Abby, your home is currently Melbourne on the coast, and that's awesome. But what about those of us that can't quite access sea turtles so easily?
Definitely just spreading the word. You know, if you learn something from a documentary or you follow a particular project, just spreading and sharing that information through, say, your social media, or just, you know, telling friends and family about, like, look at this cool project, here's what they do. That gets more people interested and involved in conservation without physically having to be sort of on the beach. So yeah, having that sharing of information is a really great way to get more people involved and aware of the threats that turtles face. And then there's changes that you can make as a consumer. So, of course, I know we've all heard it before, but trying to reduce your single-use plastic usage, and, you know, recycling, and choosing sustainable seafood as well. Small things that you can do. And I say small because I feel like we can do so much as individual consumers, but I really feel like a lot of the effort needs to come from the top down as well. So, you know, really pushing for the bigger sort of organizations and corporations to make a change. So one really great success that we saw was, you know, having the charge for plastic bags, for example, which greatly reduced people buying the plastic bags at the supermarket. And I think from a Beach Clean survey, after they introduced that, the number of plastic bags on the beach went down by 50%, which is really amazing. And then, of course, there was the big push towards McDonald's to stop them from using the plastic straws, which was started by a consumer, and that was really successful. And now they have paper straws. So I definitely think trying to, you know, if you've got something that you're passionate about, definitely trying to push organizations to be more considerate about the environment and the effects that they have on wildlife, to push for a change, as well as the individual things that you can do on a day-to-day basis.
I adore that message there, Abby, because it's spread that education. Go and get your facts,
tell everybody.
Get the information. Yeah, tell everybody and spread it with education and just the wonderful knowledge that people gain from all of the different people like yourself that are working on projects like this. And actually, I didn't even know that about, because the plastic bags, and I become some kind of awareness of once the ban had happened or the charge had happened of that big drop. And just thinking about it, like, I did a beach clean just the last few days, and yeah, plastic bags aren't really what we, at least on our beaches, it's not what we really see. It's like the odd one. What we see is sewage waste and wet wipes and things like that. So it's other things that people need to be aware that of either disposing of properly or not using, because there is so much plastic in these things. But I think we're definitely all becoming a little more, I've never said this word, woke about it than what we used to be. And just thinking kind of, actually, I'm going to ask Lexi if she has any more questions for you first before I ask this next one.
I don't know. That depends what your next question is.
Well, I was just thinking that Abby has had, I can imagine, some amazing little different experiences, not little, but like varied, little was the wrong word, experiences with just the sea turtles. And I know from experience, like, I can remember seeing my first nesting turtle on a beach and having like a mama like come out of the water next to me, and I'm sat there like, oh god. And I just was going to ask if you have some cool anecdotes from your experience, or like your favorite conservation story, or just anything like that, because I feel like we've literally scraped the surface here with a lot of the work that you do, and all of your experience, because you've done so much.
I can definitely, I've got so many favorite experiences, but one that I definitely remember, and it really makes you think because, I'll never get old of seeing sea turtles or sea turtle hatchlings or freshwater turtles. They're always amazing to me. But you have to remember that some people literally will only see wildlife on TV. So when you have someone that's seeing turtles for the first time, it can be so special and so magical for them. And it's really important to not forget that even if you see that every day as a biologist, like this is something that can be so rare and special for people. So yeah, we had one lady with us in Costa Rica. She wasn't volunteering. I think she was just on holiday with her partner. And she would come by the hatchery and she was so keen to see a sea turtle hatchling. I think they'd tried a couple of years before. And just by luck, she came by and we were doing an excavation and we had a lovely little bucket of olive ridley sea turtle hatchlings. And I took them over to her and she cried for like maybe 15 minutes. She was so emotional. She was just so amazed. It was lovely. She's like, "Oh, you've made my holiday. This is the most amazing experience." Because she wanted to see them more than anything in the world. And it can be easy to forget how special it is, when you're doing excavations every day and you see hatchlings every day. They are truly so special. And to be able to witness both nesting sea turtles and hatchlings or any turtle is a real privilege. It's a really special moment. I can't really describe it in words. Yeah, it's amazing. So yeah, that was definitely one of my favorite experiences. And then I guess just a little quote, like in my day-to-day life, I like to say like, "Oh, just keep swimming," like a little turtle hatchling, because conservation can be hard, as I'm sure you both know. It can be long hours and all kinds of weather, and then aside from the field work, just all of the desktop stuff, it can be a lot of hard work to actually get into conservation. And your hard work does pay off, and you will get there eventually, even when you have days where you're working crazy hours and there's just so much to do. Like, just keep going. You'll get there. And yeah, it's really, really, really worth it.
I think that is such a lovely quote, sentiment, anecdote, story that you've shared. I think this has been a wonderful podcast today, and I've learnt new things about sea turtles, and I've absolutely adored speaking to you, Abby. But before we wrap up, is there anything else you'd like to mention that we haven't got a chance to?
Gosh, I hope everybody loves turtles as much as I do now.
I feel that you may have ignited one or two passions, just saying. But no, thank you so much for chatting to us today. Like I said, it has been wonderful and lovely, and I adore your view on the world, and the way that you experience things with and through people. That is, I relate to that so much. But yeah, thank you so much for today. We really, really appreciate it. I haven't got any other questions. I'm just sitting here in a little bit of awe. Hannah, would you like to add anything before we sign off?
No, that was amazing. And I think that's such a great note to end on, of just keep swimming. Everyone gets there eventually. It doesn't matter where you are right now or how old you are or anything like that. So I think that was an amazing note for Abby to bring in and end on there. So all I have to say is thanks for chatting to us, and everyone that's listening, thank you to listening to us, and have a wild day. Bye.
Bye.
Thank you.
Thank you for listening today. As always, we have been Wild About Conservation, and you have been awesome. Please do leave us a review. We would really appreciate it, and we do read them all.
To keep exploring with us, drop us an email or find us on our socials. All the links are in our description and the show notes. If you enjoy our show and want to support us, we are also on Patreon. Just £1 a month, 25p an episode, will cover our creation costs, and anything above that we donate to charity. Thank you to those of you that are already helping us to keep creating.
Our chosen charity for this season are the British Divers Marine Life Rescue, who are an organisation dedicated to the rescue and well-being of all marine animals in distress around the UK. Donations will go to training teams of volunteers and maintaining specialised equipment that is vital for their work.
Don't forget to look out for our next episode next Wednesday, wherever you get your podcasts. If we aren't there, do let us know.
And remember, step outside and get wild about conservation. Bye!
How do you get wild?
Watching wildlife documentaries.
Wildflower painting.
Diving.
Wild swimming.
Ocean watching.
Rock climbing.
Bird watching.
Listening to podcasts.
Hill walks.
visiting a wildlife charity,